Hi, this is Ms. Bacon, and this is a practice videocast for ionic bonding in Science 10. When atoms combine to form compounds, the link between them is called a chemical bond, and it's the electrons of each atom that react to form the bond. One type of bond, the one we're going to look at today, is called an ionic bond. Ionic bonds always form between metals and nonmetals. They form between ions. Let's put that in there. And they can also form between polyatomic ions. They form as a result of collisions between the atoms. And it's the forces of attraction between the positively charged cations and the negatively charged anions that cause the bond to be formed. When ionic bonds are formed, electrons are transferred. Atoms must collide with one another to form a bond. When they collide, their orbits or electrons in their valence shell make contact. The atoms have to be in the correct position, and they must have enough energy for the bond to form. So we're going to look at some models of ionic bonding, both Bohr and Lewis, and I'm just going to draw them on a piece of paper here to show you what's going on. So remember that all atoms are trying to get a complete or full valence arrangement, just like noble gases. So here's some examples. The classic one is sodium and chlorine. Sodium's a metal, and it's atomic number 11, so it has 11 protons and 11 electrons in its ionic form, or neutral form I should say. So let's draw the Bohr diagram for that. Sodium, so it's going to have 2 electrons in the first, 8 in the second energy level, and 1 in the third. And that's the neutral atom of sodium. And then we'll draw chlorine, and chlorine is a nonmetal. And it tends to gain electrons and have an overall negative charge. So let's look at the atom, and we'll draw the Bohr again. And chlorine is atomic number 17, so it has 17 protons and 17 electrons in its neutral form. It's also in the third period, so it's going to have 3 energy levels or orbits, 2, 8, and that's a very squiggly one, 7 valence electrons. So we can show what's going to happen is the sodium's valence electron is going to be transferred to the chlorine, giving it a complete valence shell. So we're going to rewrite those showing the compound that's formed. So sodium has lost electrons, has 11 protons and 10 electrons, so it has an overall charge of +1. And we show that with brackets and write the charge up there. Chlorine gains an electron. There we go. So it has complete valence shell now and has an overall charge. So that's how you draw a Bohr diagram of an ionic compound. So while we're at it, instead of Bohr, let's do a Lewis diagram. Here's an atom of sodium with its valence electron, an atom of chlorine with its 7 valence electrons. We can show the transfer using an arrow. This arrow here means produce. And then we get sodium chloride. So this is the Bohr diagram for the formation of that compound, and this is the Lewis. Let's look at a little more challenging compound. Let's look at magnesium and fluorine. So magnesium is the metal, fluorine is the nonmetal. Magnesium has 12 protons, 12 electrons, and it has 3 energy levels. So do the Bohr diagram first. 1, 2, 3. And it has 2 valence electrons. Fluorine. 9 protons, 9 electrons in the atom. There we go. So, using what we've just learned, we can see one of those magnesium electrons will be able to complete the valence shell of one fluorine, but that still leaves that electron. So what we can have in a reaction, you'll have many atoms of the different elements involved. So if we have another fluorine, that'll take care of that other electron. So we'll draw the compound, the product of this reaction, magnesium fluoride. I'm going to start with magnesium in the middle. It's lost its 2 electrons now from its outer energy level, and it has an overall charge of +2. And then I can put the fluorine over here now that it has a complete valence shell. And it has a -1 charge. So these are the conventions, the brackets. Oops. And I can draw another fluorine ion over here, and there I have magnesium fluoride. And similarly, we'll do the Lewis diagrams for that, just because they're easier. So there's the ion, and there's one fluorine atom, and there's another fluorine atom, and I think I called that an ion, and it's not, it's an atom. And so one electron can go there, and the other electron will go there, transferred, and it will produce. Now we have a +2 magnesium ion bonded to, very strongly bonded to 2 fluorine ions to make magnesium fluoride in the Lewis diagram. So, in summary, after electrons are transferred, the electrons have been moved from one atom to the other. Atoms have been changed into either positive or negative ions, and strong bonds are formed as a result of the attraction between positive and negative ions.